So let's look at another type of question. Okay, they will give you 3 points on the plane, and they will ask you to find the vector equation of the plane by using the given points. Okay, so if I draw this, let's say this is the origin. Okay, let's say this is the origin. So here we have I, K, and J dimensions. So this is the origin, and if I draw the plane here, okay, the plane looks something like this. Okay, the plane looks something like this. They're saying A is present, B is present, and C is also present in the same plane. Okay, and now we have to find the vector equation of the given plane. Here, what we have to do is, okay, here we have ABC, right? So, if we find AB or BC or AC, we can come up with three direction vectors. We can come up with three direction vectors. We can come up with three direction vectors. And we already have 3 points on the given plane. We have 3 points on the given plane. So therefore, since we have a position vector of a point on the plane and two direction vectors, more than two direction vectors, we can come up with the vector equation of the given plane. So first of all, let's find out AB. Yeah, it doesn't have to be AB, it can be BA or it can be BC or CB, it doesn't matter. Just we need two direction vectors. And the thing about these direction vectors, why I call them direction vectors, well, they lie on the given plane. Okay, they lie on the given plane, so they must be parallel to the given plane. So AB can be written down as B minus A, and B is equals to 314, and A is equals to 123. So the vector will look like 1 comma minus 1 comma 1. Okay, so this will be AB. Okay, 1 comma minus 1 comma, and oh, not 1, 3 minus 1 is 2. Okay, so it will be 2 comma 2 comma minus 1 comma 1. And we can also find BC. Okay, we can also find BC. BC will be equals to C minus B. Okay, C minus B. So C minus B can be given as 0 minus 3 minus 3, and we have 5 minus 1, which is 4, and 6 minus 4, 2. Okay, so we have two direction vectors. And we can use any one of this position vector, OA, OB, or OC, and we can come up with the vector equation. So pi can be given as R equals to, okay, 1, 2, 3 plus lambda into 2 minus 1, 1 plus mu into minus 3, 4, and 2. So this is the vector equation for the given plane phi. This is how you have to do it. Now it's your turn. Now try it by yourself. Okay. So if we draw the origin, first of all, let's draw the origin. So here we have I, we have K, and we have J, and this is the origin. So if I draw the plane looks like this. Okay. And let's name the plane as phi. Okay. And they say A, B, C lie on the plane. Okay. So you can find out AB first. Okay. So first of all, we need two directions. So we will come up with the direction vectors. AB will be given as B minus A. So that can be given as minus 1, 1, minus 2. Okay. And similarly, BC can be found. Okay. So BC can be given as C minus B. So that will be equals to 1 comma minus 6 comma minus 1. So the equation can be given as phi can be given as R equals to 2, 4, 6. It doesn't have to be A. It doesn't always have to be A. You can also write down 154, or you can also write down 2 minus 1, 3. Okay. Plus lambda into minus 1, 1 minus 2 plus mu into 1 minus 6 minus 1. Okay. So this is the practice question that you can do. But one specific thing that you have to keep in mind is, okay, the points they are giving should not be the points of a straight line. Okay, so let's say this is the origin. Okay, let's say this is the origin. So here we have I, K, and J, and we can name this as O. So if I draw the plane here, okay, the plane looks something like this. Okay, so here the thing is, we have A here, we have B here, we have C here. We don't yet know whether they lie on the same line or not. Okay, whether they are parallel to each other or not. So let's find out AB first. Okay, so AB will be equals to B minus A. So B is 101, so A is 123. So the output will be 0, -2, and 2. Yeah, the 0, -2, and -2. Yeah, 0, -2, and -2. Now we can find out BC. Okay, so BC will be C minus B. So that will be equal to 0, comma, 4 minus 0 is 4, and 5 minus 1 is 4. Okay. So here the thing is, okay, here you can clearly see AB is parallel to AB is parallel to BC. Why is that? Well, you can say BC is equals to minus 2AB. Okay, so therefore we can say they are parallel to each other. So the direction vectors are, okay, the direction vectors are actually parallel to each other, which means ABC lie on a straight line. ABC lie on a straight line. Why? AB is parallel to BC. Okay, AB is parallel to BC, and B is a common point in this line. So AC is a straight line. Okay, here we have the direction vectors parallel to each other. The direction vectors are parallel to each other. If we have a direction which is parallel to each other, we can't come up with the equation of a plane. Okay, we can only come up with the equation of a straight line. We can't come up with an equation of a plane. Therefore, in this question, we can't come up with a specific equation, vector equation for a plane. So this is another type of question. Okay, other than this, we might also face questions like this. Okay, they will give you a point on the plane and also a line on the plane. Okay, phi, as saying A lies on phi as well as L lies on phi. Okay, so this can be visualized as, so let's draw the origin first. It's always better to visualize this origin. A, I, K, and J. So this is the plane. Okay, so this is the plane. In this plane, we have the point A. Okay, we have the point A, and we also have the straight line L. Okay, that lies on the plane phi. Okay, so this is what we have been given. From these two pieces of information, we are going to come up with the equation for the vector equation for the plane. Okay, and let me introduce you how you can do this. Okay, first of all, 213. Okay, 213 is a point on the line. 213 is a point on the line. So let's say that is B. Okay, so B. So we can say B is equals to 213, which is OB. Yeah, B is OB. So if I draw the arrow from the origin, okay, if I draw the arrow from the origin, this is what we call B. And we already have A. Okay. And the thing about 257, okay, I have already taught you, if a line is parallel to the given plane, the direction vector is also parallel to the given plane. And since this line lies on the plane, we can definitely say it is parallel to the plane. Okay, so 257, the direction vector, let's say this is D. Okay, let's say D is given as 2, 5, and 7. Okay, I can say that D is parallel to L. Okay, D is parallel to L. And since we know L lies on the plane, L is parallel to phi, which implies D is parallel to phi. So D can be used as a direction vector. Now we need another direction vector, and that's where AB comes into play. We can have AB as another direction vector. Okay, so we will have AB a direction vector. Let's say that is X, and we also have another direction vector, that is D, and we have 2 points. We have A456 as well as 213, which lies on the plane. Or you can substitute value for lambda and come up with different values for the points on the plane. Okay, because the line L lies on the plane, which means all the points on L will also lie on pi. Okay, so let's come up with the direction vector first. Let's find out X, which is AB. AB will be equals to B minus A. Okay, and B is 2 and 3, A is 4, 5, 6. So 2 minus 4 will be minus 2, 1 minus 5 will be minus 4, 3 minus 6 will be minus 3. Okay, so this is all you need, because now you can write down the vector equation. R equals to You can either write 2, 1, 3 or you can write 4, 5, 6. I'm going to go with 2, 1, 3 plus S into, okay, one direction vector you can use as D. So let's write down 2, 5, 7. And for another direction vector, you can write down this guy, minus 2, minus 4, minus 3. But this is equal to minus 2, 4, 3. Okay, minus 2, 4, 3. So BA can be given as 2, 4, 3. Okay, you can also use BA if you want. Okay, because that also lies on the plane, right? It doesn't matter which direction it lies on, but it lies on the plane. So you can write down 2, 4, and 3. Here also there is a small problem. Okay, you have to make sure, okay, you have to make sure that the point they are giving, okay, you have to make sure that the point they are giving, see, in this question we had A is 4, 5, 6. Okay, we have to make sure that this does not lie on L. Okay, because L was given as R equals to 213 plus lambda 257. Okay, so you have to make sure A does not lie on L, because if it lies on L, okay, in the plane, if A lies on L, you can't come up with another direction vector because A is already in the point. I mean, in the line. A is a point on the line. So you can't come up with a direction vector. So you have to be clear about that. So how can we make sure that? Well, here we will use the parametric equation of the line. So for L, okay, for L, the parametric equations are x equals to 2 plus 2 lambda and y equals to 1 plus 5 lambda and z is equals to 3 plus 7 lambda. Okay, so for A to be existing on L, okay, x has to be equals to 4. So 4 will be equals to 2 plus 2 lambda. So lambda is equals to 1. Okay, and we will sub this value for y also. Okay, so this is the second equation, this is the first equation, and also the third equation. So sub lambda equals to 1 in 2. Okay, so in that case, if A lies on L, y should be equals to, okay, the left hand side. Okay, the left hand side should be equals to 5. Okay, but what about the right hand side? If lambda is equals to 1, 1 plus 5 into 1 will be equals to 6. Since 5 is not equals to 6, we can say A does not lie on L. Does not lie on L. Therefore, you can use this data to come up with the vector equation of the plane phi. Okay. So first of all, you have to come up with the parametric equation. So for L, x is equals to 5 plus 6 lambda, y is equals to 2 minus lambda, z is equals to 9 plus 7 lambda. Okay. So if x exists on L, if x lies on L, x value must be equals to minus 1. Okay, so which implies that is equals to 5 plus 6 lambda. So minus 6 is equals to 6 lambda. So lambda must be equals to minus 1 according to the first equation. Okay, so if I substitute minus 1 in the second equation, sub lambda is equals to minus 1 in second equation, what will I get? Well, y is equals to 3 if x lies on L. So y is equals to 3. So 3, well, this is the left hand side. Now we are talking about right hand side, which is 2 minus minus 1. That is also equals to 3. Similarly, you will sub it for the third equation also. Sub lambda equals to minus 1 in 3. Okay, so z will be equals to 2. So let's check about RHS. RHS is given as 9 plus 7 lambda. So that is equals to 9 minus 7, which is equals to 2. So this implies that x lies on L. Therefore, you can't come up with the vector equation for the plane because the equation will be a equation for straight line.
Thanks for watching the 29th video in our vector series. If you found these practice questions on the vector equation of a plane helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.